Hello, we'd like to talk to you about generative learning. This was an idea put forward by Logan Fiorella and Richard Meyer in their 2015 book, and it was based on 25 years of research into effective learning strategies. And we've got a book that's going to be coming out in September the 18th, looking at how these learning strategies can be put into action. So that's what we're going to talk to you about today.
Okay, my name's Zoe and Mark. I've written the book alongside Mark. I'm currently a lead specialist English advisor for the education people working across Kent. I did spend 20 years in the classroom and have held various roles as head of department, SLT, whole school literacy, all sorts of things, ITT, professional mentor and those kind of roles. I'm also a contributor to the Times Ed and a writer, obviously, with this book.
And I'm Mark Enser. I'm Head of Geography and Research Lead at Heathfield Community College. I'm also a test columnist and author of many books. It's a bit of an addiction.
Okay, what makes this particular piece of research so exciting for me is that to me it comes across as the flip side of Rosenshine's. Lots and lots of people have heard about Barak Rosenshine's research. There are many schools that are using that as a kind of a linchpin for a lot of their development. And the beauty of Rosenshine was the fact that it made really clear what effective instructors actually did and the different processes that they would go through in order to give the best opportunities for their students. The flip side of that with the generative learning then is really clarifying what are those best bets that we can have for the young people's learning. It increases the visibility of what goes on inside the learner's mind as far as that is ever possible. And it gives us a really strong indication of what the students need to do once we have worked through that effective instruction for them.
So their work is based on Richard Meyer's SOI Model. And I think this will be familiar to a lot of teachers, this model of how memory works. And what it suggests is that information comes in, so there's an input of information from our environment, and that comes into our senses. We then have to select from that information by deciding what to pay attention to, and whatever we pay attention to then comes into our working memory. There's a limit to how much can be held in our working memory at any one time, and we're constantly rehearsing things within our working memory to keep it in place, and we're also organising new information in our working memory. Through this organisation, we're then encoding it into our long-term memory, and then that long-term memory forms schemas, webs of knowledge about things that we know, that we can extract information from back into our working memory to think about. What the SOI model suggests is that for generative learning to take place, pupils need to go through 3 steps. They need to select relevant information from, it could be from their teacher explanation, it could be from a page of text that they're reading, it could be from diagrams, photos, video clips, whatever resource you're using in the classroom. So they select what's relevant from this information for the task that I've been given. They then have to organise that information. They can't simply record it as it is. They have to put it into a new form, and then they have to integrate what they're learning about now with what they already know. So they have to integrate this new information into their schema, into their web of knowledge. So 3 processes underpin all 8 of the generative learning activities: select, organise, and integrate.
Okay, there are 8 strategies in total which have come out of the research as showing the strongest evidence base for what is actually going to make a difference. And as you can see them, I won't run through all of them, but we'll just give you a taster of what that actually means when you're using them in the classroom.
Okay, so one example would be mapping. So mapping as a technique is something that's used by a lot of students and a lot of teachers. So the idea of creating a mind map. Here's some information, make a mind map about it. The problem often is that when students create a mind map, they put something in the centre and they just record everything they know about that topic around the edge. So we might say, oh, create a mind map about Typhoon Haiyan in geography, and they just put down all the things they can remember about Typhoon Haiyan. What generative learning suggests is that actually we need to think more carefully about the processes that pupils go through in creating a mind map, that they're going through that, select relevant information, organise it into a structure, and then integrate it into what they already know. So as an example, we kind of come back to Typhoon Haiyan. Maybe they're going to organise the information into cause, effect and response, and then they're going to break up effects into immediate and long term, and the responses into immediate and long term, or they're going to look at the effects into social, economic and environmental. So they have all of these strings coming off their mind map, and they're organising the information around it. And then we'll ask them to integrate their prior knowledge into that. So what else do you know about these hazards that you can now include onto your mind map? So this new information goes into your existing knowledge.
And now I know as a teacher and as a parent I probably shouldn't have favourites, but I would like to talk about the self-testing, because it is definitely one of the elements which I think has got the most potential. Certainly it's something that I've used a lot of in the classroom myself. Testing, we know, in itself has huge potential for students, and there are many, many teachers out there who are using testing, building on the car peak and Roediger model of the testing effect in order to actually make this a learning strategy. And the same is true of self-testing. And when we get students really having that key understanding of what their own strengths and weaknesses are through the processes of self-testing, that's when it becomes even more powerful. So just as Mark said with the SOI model, students would need to select information in order to answer particular questions, maybe even designing some of those questions themselves or having them supported through the teacher designing those questions and giving them that structure for that. So they will select the relevant information. They need to reorganise that information in order to be able to answer the questions just as they would if they were testing elsewhere. And then that becomes integrated. The difference, of course, with self-testing is that the students are very much in control of that, and they are very much thinking about the processes that they're going through in order to be able to organise their responses.
So there's a range of benefits to generative learning, and we're just going to kind of discuss a few of them here. We go through more in our book. For the first benefit, it is a huge one, is that it really helps to make sure that learning sticks. It answers that question Zoe was saying, what is it that pupils actually do? When the instruction stops, what happens next? It encourages pupils to think hard about the information that they've been given. They're not simply transferring the information from place to place, they're having to select, organise and integrate in all of these different strategies. So we can kind of think about Willingham's idea that memory is the residue of thought. If you want someone to remember something, they have to think hard about it, and generative learning ensures that that happens. So the learning becomes much more sticky.
And we touched on this also previously, and it is within the SOI model, the aspects of metacognition and motivation, the two M's as Fiorella and Mayer label it in their own research. But we know metacognition can have huge impacts for student outcomes, and we know that's particularly true when we're talking about disadvantaged students. And using generative learning strategies give us the perfect opportunity to ensure that students are really developing these processes. So, for example, if we were to take summary as an example, as you took students through those processes and you modelled yourself what you were doing at a metacognitive level, students begin to see ways that they can select their own tools and their own knowledge in order to be able to build their own summaries. This, of course, in turn, then increases their own self-regulation as they become much more aware of the different knowledge they're using and the different aspects that they're drawing on. And the self-efficacy then leads us into that huge element of motivation as students realise that even the more complex tasks they're able to tackle because they have got these processes that are underpinning them every time they attempt to do anything. So that brings us to the ultimate that all teachers are aiming for and all educators aim for, is that students become increasingly independent. So as they become more familiar with generative learning, and as we use these strategies more effectively with our students, we are building students who are becoming much more independent and able to deal with those even more challenging tasks that we present to them.
I think the other real benefit of generative learning is the help that it gives when it comes to revision. Huge numbers of pupils start with this assumption, I don't know how to revise. No matter how much time you spend telling them what they could be doing to revise, but generative learning really gives them the techniques that they can then use to revise themselves. All of those 8 different strategies can be used by pupils as revision techniques. And again, it overcomes that problem of revision just being about transferring information. So I know a lot of pupils, when they revise, they look through their notes, they make notes based on their notes, they turn their notes straight into a mind map, which involves transferring their notes into a pretty diagram with some colours and highlighting, but none of it involves thinking hard. If we teach them how to use the generative learning activities in class, they can then use them as revision activities as well. And so we get a double hit on it. I think that can be incredibly powerful.
And students with greater metacognitive abilities and processes and understanding of that will be better at using those revision strategies.
Oh yes, that's the holy grail right there. Now, as with anything, there are potential pitfalls when it comes to applying these ideas in the real world, and we need to be very, very aware of them. And our book deals with them in quite a lot of detail. One of the big things we have to do is make sure we're choosing the right generative learning activity for the right pupils at the right time. So one thing to consider is some strategies, like in acting, for example, really come into their own when pupils are struggling to move between the concrete and the abstract, and enacting things enable them to make that link. Now, that's true of very young children. It's not really true of teenagers. And actually, trying to use enacting with teenagers just puts another barrier in the way of what you want them to learn. They're having to think about something else and not the material. So it wouldn't, I don't think, be especially applicable to teenagers. We wouldn't use that strategy with them. We'd use it with much younger children. On the other hand, things like self-testing requires pupils to already have the knowledge in place with which to think about and to be tested on. So we can't use that with absolute novices in a new subject. They need that knowledge first in order to use the self-testing strategy. Other things to think about are the kind of subject implications. So creating summaries as a generative learning activity works really well if you're studying blocks of text in any subject and summarising that information as you read through it. It doesn't work very well in a subject like science, where a lot of information is already presented in diagrams or tables because it's already been summarised. And trying to produce a summary of it just means that any kind of meaning is lost. It's already organised in that way for a reason. So we do have to think quite carefully. What we really can't do is say to staff, this week we are doing summarising, go and do lots of summarising, or we're going to end in chaos. Which brings us to staff development.
Absolutely, and something that I'm really passionate about, and as many of you will be. We need to make sure that with anything that we're using, any strategies that we're bringing in, that we're really investing in that staff development. So if we look at generative learning and we think that has a huge amount of potential for our students, which I believe that it does, we need to make sure that we're really supporting staff in working through that. So making sure they have a really strong understanding of what the principles are that underpin that, how they can be used, why they might want to use them, and giving them that time to reflect and practice deliberately how these things could be applied. Because otherwise, we are running into that danger again of kind of silver bullets and bringing in things without that kind of fully thought out kind of focus that we want all our staff to have. So that's always going to be, my caveat on anything. Make sure that you're really investing in staff development if you think this is something that is going to make a difference for your students.
So I think in conclusion, I'll just say that I think generative learning could be the next kind of big idea in education. I think it's got a huge amount of potential if we get it right. I think what's really useful is that a number of schools, as Zoe's already mentioned, have started with this idea of Rosenshine's principles of instruction and getting instruction right. And this doesn't work if the instruction isn't right. So we have to get that right first, but this says what comes next. What is that flip side of Rosenshine? And I think it could be generative learning. Thank you very much.
Thank you.